Specification for Local Area Network LAN System Part 1. Design requirements. The Local Area Network LAN system shall be designed as a fully integrated platform to support the communication requirements of a wide range of subsystems, including Office LAN, VoIP, CCTV, PEGE, UHF Radio, and Access Control and Security Systems, ACSS. The design shall ensure reliable Ethernet signal transport across these systems by deploying a two-tier architecture comprising Layer 2 access switches and Layer 3 core distribution switches. Star topology shall be implemented as the underlying physical layout to enhance routing efficiency and network manageability. The system architecture shall be fully TCP/IP based and conform to IEEE, ISO, and IEC 802.3 standards, supporting 10-100/1000 Mbps Ethernet connections. All Layer 2 access switches shall connect to Layer 3 core switches using dual 100 Mbps BaseFX fiber optic links. These uplinks shall ensure consistent throughput, fault tolerance, and support for VLAN-based traffic segmentation. The central switches shall serve as the backbone of the communication network, handling routing functions for all interlinked telecom systems. At the remote cluster level, each site shall be connected via a single 100 Mbps SDH Ethernet interface. These remote links will allow central monitoring and management of services without requiring localized routing equipment. Ethernet distribution within the plant shall primarily use 48-core fiber optic cables, while certain key locations, such as the substation, shall utilize 96-core cables to accommodate higher capacity and redundancy requirements. Remote clusters shall be interconnected with the central LAN system via two geographically diverse 96-core fiber optic cables, one using optical ground wire, OPGW, and the other via direct buried cable. This configuration provides high fault tolerance and supports dual route Ethernet delivery. The LAN design shall employ both Layer 2 and Layer 3 switches in a hierarchical layout, enhancing scalability and control. Each of the remote buildings and cluster locations shall be equipped with a Layer 2 Ethernet switch configured under VLAN segmentation to support multipurpose system traffic. The switches shall support 10-100 Mbps configurations mapped over SDH as 5 DAVBanks VC12 or 1 DAV VC4 circuits, with 100 Mbps set as the default unless modified for specific end device requirements. The distribution or core Layer 3 switch shall be capable of supporting 1 Gbps fiber optic uplinks and must implement the spanning tree protocol, STP, to eliminate loops while maintaining redundancy. Layer 3/4 switches shall be provisioned for each major subsystem to support high-throughput data transfer and IP-based services across the entire network. VLANs shall be implemented to segregate traffic across systems and departments. The design shall allow broadcast domains to be broken down by VLAN ID using MAC-based filtering, port security, and ACL enforcement. Port-based VLANs conforming to IEEE 802.1q shall allow flexible and secure endpoint management, ensuring seamless integration of voice, video, and data. The hierarchical network model for the project shall follow a composite enterprise LAN structure with the core switches, all 48-port distribution switches, and associated application servers located in the new remote building. A centralized network management system, NMS, consisting of a server, monitoring terminal, and SNMP-based software shall be deployed for full LAN VLAN oversight. All switches, access, and distribution shall support CLI and SNMP protocols, enabling configuration, fault tracking, security auditing, and performance monitoring from a single interface. Specification for Local Area Network LAN system part design requirements continued. The Layer 2 access switches installed in each remote building and substation shall be 24-port, 10-100,000 Mbps Ethernet switches with 4 dual-purpose uplink ports. Each uplink shall consist of 1 copper Ethernet and 1 SFP-based fiber port, with only 1 active at a time. These switches must support IEEE 802.1q VLAN tagging, Rapid Spanning Tree Protocol, RSTP, Power over Ethernet Plus, PoE Plus on all ports, and be capable of classifying, marking, queuing, and scheduling packets to optimize quality of service, QoS. All access switches must include stackable functionality with dual uplinks using single-mode fiber to ensure resiliency. These uplinks shall terminate at the Layer 3 core distribution switch in the central remote building, ensuring centralized control and network loop protection. Each switch shall include onboard non-volatile flash memory to store configuration data and the operating system image, allowing automatic recovery and configuration retention during power failures. The distribution core switch shall be a high-availability, enterprise-grade Layer 2-3 model with at least 48 SFP and Ethernet gigabit ports, support for IPv4, IPv6 routing, advanced multicast handling, and modular redundancy for power and cooling units. Optional 10 GBE uplink modules and MACsec hardware encryption must be supported. The switch shall operate on a 32 GBPSS stacking bus and provide Open Shortest Path First OSPF protocol in its base configuration. The network shall employ a port-based VLAN segmentation strategy, with each telecom service, e.g., VoIP, CCTV, Office LAN, ACSS, mapped to dedicated VLAN IDs. This segregation allows enhanced control containment of broadcast domains and prioritization of time-sensitive data, such as voice and video streams. Port-based bandwidth allocation and access control lists, ACLs, shall be implemented for each VLAN to enforce usage policies and maintain security. A dedicated VLAN shall be assigned to each remote building and substation to ensure isolation and efficient troubleshooting. These VLANs will be logically separated, but physically transported over a shared fiber trunk, with trunk ports configured for .1Q tagging. VLANs shall support dynamic assignment and flexible port grouping to accommodate future network expansions and equipment relocation without rewiring. The Network Management System, NMS, shall centrally monitor all access and core switches. It shall display real-time topology maps, interface statistics, port status, bandwidth usage, event logs, and alarm states. The NMS shall also provide firmware update control, bulk configuration deployment, and automated backup of switch settings. SNMP v2 or v3 shall be used for polling and trap reception, and all switches must support MIB2 and proprietary enterprise MIBs for comprehensive status reporting. Redundancy is mandatory at all network layers. The use of 2 independent fiber optic links for each remote cluster or building, one via optical ground wire, OPGW, and the other via direct buried fiber, ensures physical path diversity. Spanning tree protocol or equivalent Layer 2 loop prevention mechanism must be implemented across the LAN to permit automatic rerouting in case of primary path failure. All Ethernet switch models must be certified and supported by the manufacturer for a minimum of 5 years from the date of commissioning. A certificate from the manufacturer confirming this support shall be included in the submission. Additionally, the vendor must provide full hardware and software support, including response commitments for fault handling during the warranty period. Final design and port assignment plans shall be submitted showing the full logical network layout, including VLAN definitions, IP addressing schema, trunk connections, and switch rack elevations. These drawings must be updated to as-built status following installation and testing and incorporated into the final handover documentation for operational use. Specification for Local Area Network LAN System Part 3. Design requirements continued. The LAN design shall account for detailed configuration requirements for access, distribution, and edge switches. This includes specific port mappings for each remote building and substation, interface types, copper versus fiber, device roles, telephony, CCTV, workstation, printer, etc., and power delivery through PoE. Every active port in the system shall be assigned a unique logical role and mapped to its associated VLAN and IP subnet. Clear port naming conventions must be applied and maintained throughout the project to ensure traceability. Edge switches intended for outdoor or industrial service, particularly those deployed in cluster field enclosures, shall be ruggedized, industrial-grade PoE Plus 5-port switches conforming to IEEE 802.3 AF standards. These switches must include 4 10100 base TX PoE Plus RJ45 ports and 1 single-mode fiber port for uplink. Enclosure design must allow operation under high temperatures, dust, and humidity, with IP66 protection and overcurrent, overvoltage, and surge protection features built in. These edge switches shall also include auto-negotiation and auto-polarity features, with switching capacity of at least 8.8 GBPSS. They must operate on low-voltage DC input with reverse polarity and transient spike protection. Support for SNMP and web-based diagnostics is required, along with VLAN support and class of service, VOS, for traffic prioritization. Installation at field locations shall be accompanied by appropriate thermal shielding or sunshades, grounding, and cabinet ventilation as per environmental specifications. All devices shall be mounted into standard 19 inches racks or enclosures with lockable front access. Passive infrastructure such as patch panels, keystone jacks, and structured cabling must meet ANSI TIA 568-C.2 requirements. All fiber optic patch cords shall be of single-mode type SC-APC or LC-APC as per endpoint interface specifications. Fiber termination and splicing must be executed to Class B or better loss budget standards with test reports submitted for each link. Each building or remote shelter must include a wall-mounted telecommunications enclosure or cabinet where access switches are located. These enclosures shall house all termination blocks, patch panels, PoE switches, grounding bars, and UPS supplies. Cable entries must be sealed against dust and vermin ingress. Adequate clearance and ventilation must be provided to maintain operational reliability under full load conditions, with thermal design calculations submitted for review. Ethernet cabling between switches and endpoint devices must use shielded Cat6 UFTP or better with flame retardant jackets and LSZH insulation. Patch cords must not exceed 5 meters in length and be factory molded with snagless boots. Field terminations are to be avoided unless authorized and must follow strict testing protocols, including continuity, impedance, next, and attenuation measurements using certified testers. For inter-switch fiber optic connections, proper bend radius management, labeling, and documentation are critical. All fiber runs must be terminated with pre-labeled tags at both ends, indicating source, destinations, and switches, core numbers, and port IDs. Redundant fiber paths must be color-coded and separated physitrays or conduits to reduce the risk of simultaneous damage. The transport protocol for remote sites shall be via SDH Ethernet modules integrated into the existing SDH nodes. All remote buildings and clusters shall use these modules to connect back to the central distribution switches via dedicated VLAN trunks. The Ethernet over SDH interfaces must support virtual concatenation and low latency transport and shall be configured for at least 100 Mbps sustained throughput with capability for upgrade if needed. At the core, a centralized management console shall provide unified control of all switch elements. Features must include real-time port activity visualization, bandwidth monitoring, alerting for abnormal traffic conditions, and tools for firmware deployment. Audit trails for configuration changes and user logins must be enabled to satisfy security and compliance requirements. Backups of all switch configurations shall be automated and stored securely within the central LAN server in-server infrastructure. Specification for Local Area Network LAN System Part 4. Distribution switch requirements. The distribution switch shall serve as the core backbone for interconnecting all access level switches across remote buildings, substations, and field enclosures. It shall be of modular, stackable design with enterprise-grade reliability and built-in redundancy features for power, cooling, and uplinks. This switch shall support both Layer 2 and Layer 3 switching and routing functions, enabling seamless integration and traffic segregation across voice, video, and data services. Each distribution switch must support a minimum of 48 gigabit ports with a mix of small form factor pluggable SFP and copper Ethernet interfaces. The port configuration shall be flexible to accommodate VLAN, SDH Ethernet uplinks, and direct server attachments. The switch shall be equipped with at least 2 high-speed 10 gigabit SFP plus uplink modules to ensure scalable throughput and redundancy in high-traffic environments. The system shall support 32 gigabit PSS or higher internal stacking bandwidth with innovative stacking technology that allows multiple units to be logically and functionally managed as a single switch. Stack management shall allow automated failover and load balancing across stack members. In the event of a unit failure within the stack, traffic must automatically reroute through alternate paths without disruption. Each switch shall be equipped with dual hot-swappable power supplies and field-replaceable fan trays. This modularity ensures non-disruptive maintenance and upgrades. Power supplies must be rated for industrial environments and provide input protection against voltage spikes, reverse polarity, and overload conditions. Cooling systems must include thermal sensors and automatic speed control based on real-time temperature readings. Software capabilities shall include an IP services feature set, IPS as standard, offering advanced routing protocols such as OSPF static and dynamic routing and multicast routing, PM. Full IPv4 and IPv6 support is required. Security features shall include MACsec media access control security, 802.1x network access control, Radius TACX Plus integration, DHCP snooping, dynamic ARP inspection, and port security with lockdown features. The distribution switch shall support hardware-based QoS and traffic shaping mechanisms. At a minimum, it must offer ingress and egress traffic policing, rate limiting, traffic classification, priority queuing, and differentiated services code point, DSCP marking. These features are vital for voice and video quality assurance and must be configured to work with VLAN tagging and class of service COS schemes. System monitoring and diagnostics shall be fully supported via Simple Network Management Protocol, SNMP-v2-v3, Command Line Interface, CLI, and Web-based Graphical User Interface. The switch shall integrate with the Central Network Management System, NMS, and support export of syslog, NetFlow data, and SNMP traps for proactive performance and fault monitoring. Each switch shall support Virtual Router Redundancy Protocol, VRRP, or equivalent for gateway failover, and must be configurable to serve as either a gateway router or distribution node based on project design. Multicast traffic filtering and control shall be implemented through Internet Group Management Protocol, IGMP, snooping, and throttling, especially where multiple CCTV or broadcast data streams are in use. The distribution switches shall be installed in a 42U equipment rack located in the remote building telecom room, secured in a lockable cabinet with cable management trays and earth bonding. All connections shall be labeled, documented, and verified through commissioning test procedures. Space must be allocated in the same rack for uplink modules, NMS appliance, and at least one spare switch for contingency. Specification for Local Area Network LAN System Part 5. Access switch requirements. Access switches form the edge layer of the LAN architecture, providing direct connectivity to all end-user devices, including operator workstations, VoIP phones, CCTV endpoints, printers, and control systems. These switches shall be installed at every remote building and substation, as well as within central technical rooms, ensuring localized traffic handling and VLAN enforcement. Each switch must be enterprise-grade, rack-mountable, and conform to IEEE 802.3 standards. Each access switch shall support 24 Ethernet ports with 10-100-1000 base T connectivity, enabling flexible deployment for varying bandwidth requirements. 4 of these ports shall be dual-purpose uplinks, combining RJ45 copper and SFP-based fiber interfaces with one active at a time. These uplinks will provide redundancy through single-mode fiber optic connections to the distribution switch layer, ensuring fault-tolerant design and scalable expansion. The switch shall provide full IEEE 802.3 AFs, 8 Power over Ethernet Plus PoE Plus support on all access ports, delivering up to 25 watts per port to connected devices such as IP phones, wireless access points, and surveillance cameras. Power supplies must be hot swappable and scalable to meet full PoE load conditions. Redundant internal power modules are preferred to eliminate single points of failure. VLAN functionality shall be configurable per port, supporting port-based, MAC-based, and protocol-based VLAN assignment methods. The switch must comply with IP 82.1q VLAN tagging standards and allow dynamic VLAN assignment through 802.1x authentication. Each VLAN shall be configurable with independent security policies, QoS parameters, and bandwidth limits. Advanced traffic management features are required, including Layer 2 QoS for packet prioritization, bandwidth shaping, and queue scheduling. The switch must support access control lists, ACLs, for traffic filtering, dynamic ARP inspection, DHCP snooping, and IGMP snooping for multicast control. These features are critical for maintaining service quality and security across converged networks. Stacking capabilities shall be included, allowing multiple switches to operate as a single logical unit. Each switch shall support vertical or horizontal stacking with other same model units, with minimum 20 Gbps stack interconnect bandwidth. Stackable switches shall support automatic master election, cross-stack Ether channel, and unified management via CLI or Web GUI. Security features must include multi-level user authentication, SSH HTTPS secure management access, Radius TACACS Plus integration, and MAC address notification for unauthorized device detection. Spanning Tree Root Guard (STRG) and BPDU Guard shall be implemented to protect the network from potential loops and rogue switch connections. All access switches shall store operating system images and configuration files in non-volatile flash memory. Startup recovery must be automatic following power loss, with the ability to push predefined configurations via the NMS or USB interface. Auto-provisioning features like smart ports or equivalent shall be enabled for consistent configuration across identical ports. The switch chassis must be 1U rack mountable in a standard 19-inch cabinet and rated for operation in temperature conditions of 0 degrees Celsius to plus 55 degrees Celsius. Front-facing ports, indicator LEDs, and cable management brackets are required. Dust filters and lockable bezels are recommended for units installed in semi-controlled environments such as shelters and field enclosures. Each switch must be labeled clearly with port maps, cable IDs, and MAC address registers maintained and submitted as part of as-built documentation. Specification for Local Area Network System, Part 6. 5-port PoE Plus industrial-grade switch requirements, optional. Where compact, rugged, and low port count connectivity is required, particularly at field locations supporting individual devices like IP cameras, VoIP handsets, or ACSS terminals, a 5-port PoE Plus industrial-grade Ethernet switch shall be used. These switches are intended for deployment in harsh environments and shall conform to industrial design standards, providing Layer 2 switching functionality, PoE Plus capability, and robust performance with minimal maintenance overhead. Each switch shall be unmanaged or lightly managed, capable of store and forward operation at wire speed, and support a minimum of 4 10100 base TX RJ45 PoE Plus ports and 1 single-mode fiber uplink port with SC or ST connector. The PoE Plus ports must comply with IEEE 802.3 AAT and be capable of delivering up to 15.4 Wh per port, with built-in support for auto detection, power negotiation, and overcurrent protection. The device shall feature wide-range DC power input, 10 to 30 volt DC for standard use, and 45 to 56 volt DC for PoE output, with reverse polarity and transient voltage protection. PoE disconnect mode shall be via DC cutoff, and automatic power management must be included to prevent overload. Surge protection shall be built in with minimum ratings of 15,000 watt peak and 5,000 watt spike suppression. The switch shall support VLAN traffic tagging, class of service, CoS traffic prioritization, and port isolation as basic traffic management tools. SNMP compatibility and web-based configuration are preferred for diagnostic purposes. Smart management features shall include performance monitoring, port enabling, disabling, error tracking, and VLAN setup, all accessible via Web GUI or designated NMS interface. Construction shall be IP30 or higher rated metal enclosure with DIN rail or wall mount capability. The unit must be fanless and operate within an extended temperature range of minus 40 degrees Celsius to plus 75 degrees Celsius. MTBF must exceed 200,000 hours, and shock, vibration, and EMC immunity ratings shall meet IEC 61850-3 or equivalent industrial standards. The fiber uplink port must support full duplex 100 megabit per set over single mode fiber with 1300 meters wavelength and a minimum transmission distance of 20 kilometers or up to 40 kilometers for long haul options. All optical transceivers must be industrial temperature grade and securely installed using dust-resistant port covers. Each unit shall have visual status indicators (LEDs) for power, link activity, PoE status, and fiber transmission. RJ45 ports must be shielded, support auto MDI, MDX, and auto polarity correction, and provide electromagnetic isolation of at least 1500 VRMS for 1 minute. The switch shall be optimized for network management software such as ProSafe NMS 100 or other SNMP-based tools, supporting event logging, port statistics, and basic diagnostics. Compatibility with Windows, Linux, and macOS environments is required. All switches shall be pre-configured off-site by the system integrator, tested for full functionality, and assigned to specific VLANs before deployment. Installation shall include proper labeling, grounding, cabinet mounting, and environmental shielding as per site classification. Final acceptance of the switch will be contingent upon verification of connectivity to upstream fiber links and successful PoE power delivery to the end device under load.